In this video, we're going to prove that the sum of the 2n minus 1 integers from 1 to 2n minus 1, the sum of these integers is equal to n squared with n in n. What does this result mean? That means is that if we want to compute 1 plus 3 plus 5 plus 7 plus 10, 17, what's this sum? So this sum is this last number plus the next. So 10, 17 plus 1 is 10, 18 divided by 2 is gonna give us 509 squared. Okay, remember this integer here, 2n minus 1, what's the next one coming after this one? 2n, we divide it by 2 and we square it to get the sum. So this is how you remember. Okay, there is another way when we can write this one as in the sigma notation is we start from k, from 1 to n, and we have 2k minus 1 is equal to n squared. So this is a condensed notation for this one here. Okay, now how can we prove this result? We can prove it using mathematical induction. Okay, and to do that, we're gonna call this statement here Pn is the sum of the odd integers from 1 to 2n minus 1 is equal to n squared. Okay, what we're gonna do is we're first gonna check that p of 1 is true. We're gonna assume that p of n is true, and we prove that Pn plus 1 is true as well. Okay, so we will explain all these steps. Okay, what does it mean p of 1? That means this statement is true for 1n is 1. So 1n is 1, there is nothing to prove, is just 1. And 1 is equal to 1 squared, which is 1. Or we can put 1 here. That means n is 1. We can put 1 here. We have 2 times 1 minus 1, which is 1. And in this case, the next number that follows 1 is 2. 2 divided by 2 is 1. And square 1, we get 1. Okay? So the statement is true for n equals 1. Next, we assume that it's true for n. That means we assume that we have this result here. Okay? We assume this is how the principle of mathematical induction works. So we assume that p of n is true. That means we assume that the sum of these odd integers from 1 to 2n minus 1 is true. That means it's equal to n squared with n in n, and we prove that p of n plus 1 is true. So what's p of n plus 1 is true? What's this one? We want to prove that the sum of the odd integers 1 plus 3 plus 5, and we stop at 2n plus 1 minus 1. So here we stop 1 plus 3 plus 5 plus 2n plus 1, and we want to prove that this one is n plus 1 squared. Okay, again, note here that 2n plus 1 is 2n plus 2 divided by 2 is n plus 1, and we square that to get the sum. So we want to prove that this one is true. How can we do that? We have one key idea that we start with. So we have p of n is true. We know that p of n means that 1 plus 3 plus 5 plus 2n minus 1 is equal to n squared. So we have this one. This is the induction hypothesis. Okay, here. This is what we call the induction hypothesis. It's true. And we have this one here. How can we get from here to here? So we know the addition. We can add numbers in n. This is in n. This is in n. So we can add numbers. So here we're going to say add in 2n plus 1 to both sides of, let's call this one star. So add in let me be nice here and write nicely. 2n plus 1 to both sides of this star here, what happens when we add that? So we get 1 plus 3 plus 5 plus 2n minus 1 plus 2n plus 1, because this is the next odd, is equal to n squared plus 2n plus 1. So I added 2n plus 1 to both sides in the induction hypothesis. So what do I have here? N squared plus 2n plus 1 is what? It's n plus 1 squared. And what's this sum? This is p of n plus 1. That means p of n plus 1 is true. That means the sum of the odd integers from k going from 1 to n plus 1 is equal to this sum. That means it's true. Okay? So therefore, I satisfied all the conditions for the induction hypothesis, and I applied and I showed that p of n plus 1 is true. That means I can conclude now. So that means that the sum 2k minus 1 with k going from 1 to n is equal to n squared for all n in n by the principle of mathematical induction. That means this result is always true. Okay? The sum of the odd numbers from 1 to n is equal to what? To n squared. To remember that, remember the last number, which is 2n minus 1, and add the next number to it. It's 2n, and divided by 2, you get n, and you square that. That's how you get this result. Okay? I think we did all the steps that we need, and we verified everything. If you see any errors or mistakes, please let me know. Thank you.